started talking about lot of real world data, and real world data sets started coming from various industrial revolution and also the different revolution that happened in this different sector of maybe understanding the particular idea about how the new markets are going to happen, about idea about understanding what going to be the forecast of maybe the number of sales if you are going to sell some of the products, and all of them thing got captured into the field of data science. So if you have heard of a very popular statistician called Taki, I think some of you have must have heard about Taki's test. Taki's statistical test is very popular in statistical test of hypothesis. He was the first person who introduced this particular term, data science, back in 1957. And after that, data science started blooming as a study of the generalizable attraction of knowledge from the data. And the term science is more important. So extraction of knowledge is more important, of course. Then, after maybe another 20 years, back in 1970s, so there was some time when something called AI winter happened. So people started talking about artificial intelligence, and in artificial intelligence, they tried to create some intelligent agents. So what these agents will do, just like an intelligence agent, if incorporated in my mobile. So suppose Google has something called Google voice recognition. If I tell, okay Google, can you call someone? Google will do it for you. If you ask Google, suppose what is going to be the birthday of Barack Obama, Google will all on a sudden give you the answer. So all these things, giving some knowledge to the computer and let the computer do some certain tasks for us, was incorporated in a big domain called artificial intelligence. And under artificial intelligence, a subfield was created called machine learning, which has this almost very much overlapping with statistics, which helps the computers the ability to learn without being explicitly programmed. So that was the time back in 1970s to 2000 when machine learning and artificial intelligence got too much attention. And these days it's everywhere. If you can open any cinema, any movies and anything like that, you will always be seeing this is AI generated one. Whatever camera you are using, it uses AI based filters, so that even if you are, whenever you are looking at my face, maybe there are some wrinkles around my forehead which you may not see because of the AI camera out there. So that's the beauty of AI and machine learning that started blooming, and right now it's on the hype. Then another most important term, at least after the COVID-19 started blooming, and then that particular term which got most attention is the forecasting. Epidemiological forecasting, pandemic forecasting, and forecasting of various economic and other variables. That got lot of attention in last few years and as well as before that. But the most interesting application of forecasting things started happening after 2000 to real world problems from economics, epidemiology, biology, and so on. So forecasting is regarded as estimating how the sequence of observations will continue in the future. Suppose we want to understand currently the unemployment rate in India is suppose 10%. What will be the unemployment rate for India maybe next couple of years? If we can learn that, if we can understand that, then maybe we can design some public policy. We can discuss with government so that they can try improving that particular fact. If it is going to incline or decline, based on that, we will be taking the measures. If it is going to be decaying, so then we'll be having like the feelings that we are going to be get paid after we complete our graduation or post graduations. So just like that, maybe exchange rate. Suppose since I live outside India, for me, which is most important thing is called the exchange rate. So I need to check whenever I want to send some money to India, I have to check whether the exchange rate price is right now at the higher side or at the lower side. So all these forecasts, so if we get some good forecast about the exchange rate maybe for next 7 days, then I can plan my bank transfer accordingly. And all these things are very useful in not only in those real world problems, but also whenever we make some prediction in real life also we make the use of forecasting, not by statistical forecasting, but maybe some heuristic methods we always try. Just like if suppose you are going to leave your home today and it was raining yesterday. So your mother may ask you, can you please take umbrella because I think it will rain. She is also going to make a forecast about the rain, right? So how does she do? She might be looking at the sky and based on her experiences over last 40, 50 years, she will understand that, okay, so if the sky is looking something like this, it may rain. So we already are doing forecasting without knowing so far. So I'll take you through a very brief past about a very detailed past, not brief actually. So I'll take you through some of the forecasting that happened in the past and how did it happen. So I'll take you to 700 BC. So it's like before the calendar was formed, right? So the Jewish prophet Isaiah wrote in 700 BC that if someone can tell us what the future holds, so we may know that you are gods. So that particular line was encrypted back in 700 BC. And after 100 years later, there was in ancient Babylon, forecasters would foretell the future based on the distribution of maggots in a rotten ship's liver. So as you can see, this is a picture of that particular ship's liver. This is known as clay model of ship's liver. And this was used for forecasting by maggots. And right now it is kept in British Museum. If you sometime go to UK, you might be seeing this particular clay model of ship's liver. And they have been using this to make the forecasts. Whatever we called in astrology or something like that earlier time maybe. So those predictions they used to make, they used to tell about, okay, tomorrow this is going to happen based on looking at this particular clay model of ship's liver. That was back in 700 BC and 800 BC. Then around the same time, some of the people, they started making forecast by using the technique called hallucination. What they used to do? They used to, people want to forecast, would take their journey to Delphi in Greece. So there is a place named as Delphi in Greece, where they used to go to consult the oracle. What this oracle would do? Oracle would provide forecast prediction while intoxicated by ethylene vapors. So it will give you a pot, there will be ethylene vapor, you will be intoxicated by that, and after that, the person will be telling you your future. So those black magics, right? So, but they were making those predictions, right? By that, whether they were making correct prediction or wrong, that is the second thing. We will be coming into later. But all of this thing was happening, but some people, they started pushing it back. Just like Codex Theodosius was one of the person back in AD 357 who particularly told not to consult any mathematician or forecaster or soothsayer. If you do that, you will be having some penalty, and it could be a death penalty as well. So that time, forecasters or those who are talking about the future, they had a really tough time. And then it got enhanced. Let us come to 700th century when a similar ban on forecasting occurred in England in 1736, when it became an offense to defraud by charging money for predictions. Suppose right now in India, even if you go to some places, we see a lot of those advertisement of people who will be telling your future by taking some money, those astrologers and so on and so on. But back in 1736 in England, it had been banned, and that is known as British Vagrancy Act back in 1736, and which made it offense to defraud by charging money for predictions. The punishment that time was 3 months imprisonment with hard labor. So suppose someone asks you, how are you going to make the prediction? There can be two ways. One is try the crystal mambo jumbo zoom, something like that. You'll have a crystal ball. You'll be telling the person to hallucinate, and you'll be making the prediction. You had another option called statistical probability, which started emerging in the field of forecasting after 1950s. And then there is also another correlation between the forecasting things with the physics. Just like in astronomy, ancient Greeks developed some prediction models of cosmos used for astrology. Celestial bodies moved around the earth in circles. So that is what they have been thinking. And finally, the church has implemented this model. They started teaching this nonsense to other peoples. Then finally, at the time of Renaissance, Galileo Galilei, Copernicus, Kepler, they came and they tried to protest against this. So people's forecasting got so ugly that like it was so wrong at some point of time that some people even got sentenced for telling the truth, just like Galileo Galilei. So forecasting has its very beautiful as well as ugly past. So in which forecasters, they have made some forecastings. In some sense, some of them were correct, just like whosoever started using mathematics and statistical methodologies, they tried to be more correct than those who were using something called this Nambo Jambo Jumbo. So that was the something that started happening from 700 BC to up to here. Right now, I'll tell you about some of the very interesting forecasts that either made reputation or lost its reputation. Just like the chairman of IBM in 1943 told, I think there is a world market for maybe 5 computers. Do you know what happened? After 1943, IBM started making computers, and still like IBM was still popular. When I was in school, I was using IBM computer in my school. So the chairman of IBM made some particular forecast which was so true and made so much reputation. Whereas the president of DEC computer, have you ever heard of DEC computer? If I ask you this question, you may not know. So the DEC computer was something that was back in 1980s, 1970s, 1980s. They made some statement, there is no reason anyone would want a computer in their home. And after 10 years, the DEC computer was dead. They sold their company and there was nothing called DEC computer after that. So that's how people have lost their reputations by making some predictions. So whenever you are making predictions, be sure you are being more than 95% sure or some percentage of sure while creating those particular points, assumptions and everything like that. Because it will either make your reputation good or you will be losing your reputation for this. Just like the CEO of Microsoft back in 2007 told there is no chance that iPhone is going to get any significant market share, no chance. But it proved wrong. Then Donald Trump, just like in February 2022, you remember, I think all of us remember March 2022, what happened in India, the lockdown and everything. I think that should be celebrated as a Black Day. But anyway, in February 2020, when there was no lockdown in India and so on, Donald Trump, the president at the time of United States, told that we are going to be opening relatively soon, the virus will go away in nothing. So you know what happened next, what happened with the election of presidential election in US and Trump lost and everything happened. So by making predictions, by making the forecasts out of sample predictions or forecasts, you can really make your reputation or you can lose your reputation. So, but you should remember this thing, if you are going to be a forecaster, forecasters have been blamed some of the times. Just like in 2006, there was a news report which reported on 16th of August, a Russian woman has sued weather forecasters for wrecking his holiday or her holiday. So they went to court because the particular weather forecasting thing told that there will not be any rain for the next day, and the particular woman actually planned her trip and went somewhere and there was a heavy rain and she got cold. And then she went to the court and asked that particular weather forecaster should be penalized for that. So you know that is also happening back in 2006. Still now, even if you make some forecast about something, knowing maybe some particular opinion about any company, maybe some internal information about some of the companies, and you make some forecast about their stock prices, if the government get to know that you have leaked some of their internal informations, you might be prosecuted. So forecasters
हाँ यार
got
नहीं
blamed
नहीं
in
लग
some
रहा
of the
है
times. There is a very
अरे कुछ नहीं
interesting
यार मेरे
write-up
मैंने
by
वाली टिकट
Max
कितने देना है
Walls. It was
महीने में
in
क्या
the
लगेगा
age
तुम्हारा ट्वेल्थ वाले
1993. He said there are four
नहीं
ways
जा रहा
economists can lose their reputation. So, in case you are from economics background or if you
अच्छा
are
फ्लैट में
interested
जाएगा
about
क्या तुम
economic statistics,
अच्छा कितने
so
बजे जाएगा तू
what are the ways one economist can
शाम
lose
को
their
7 जाएगा
reputation? One is gambling. Gambling is the quickest. Sex is the most
अच्छा ठीक है
pleasurable, and drink the slowest.
अच्छा
So
चलो
if
ठीक है
you
पार्टी
got
वार्टी करेंगे
drunk
ठीक है
regularly, it could be a slower, but you will be losing
गेम
your
खेलेंगे
reputation. But forecasting is the surest. So you can understand what people like. There have been so much positive and negative thoughts about forecasting before at least 2000 and after 2000 still. Right now, let me take you through an interesting problem which tells us how important the
तो हम
forecasting
तो
will
अभी
be.
तक पता नहीं कहाँ कहाँ फिर गए
Suppose someone like your maybe your
हाँ
grandparents, if you
हाँ
have your grandparents, if you ask them back in 1970s, what was the what was $1 versus INR? They might be
अरे
telling that
भाई
it
जो
was
ट्वेल्थ
very
में कल
close,
तक रुक जाता है ना
it
एक
was
आदमी
not like that.
तो
Just
फिर
like you
वो
can
बोल देते
see,
हैं कि हाँ कोई
at
बात नहीं
least till
हाँ
1990s, even before 2000, $1
हाँ
used to be less than 20 rupees. Then everything got changed, and right now we are in middle of $1 is approximately equal to 75 rupees. So these are the particular data sets which
हाँ तो फिर
integrates
कल
us,
तक
or
कल
like
दिन तक
tells
होगा
us that there is a passion that you
हाँ
will be
ऐसे ही
following if
बोल
you
रहा
are a
था तू है तो
statistician
सही
to
है
involve and get involved in doing forecasting
तो
about
पता
the
नहीं लगता इससे
future.
निकलते हैं हम
So
दिखते
this
हैं
is one of the example where if you plot the monthly data sets of the average sale, average
अरे यार मैं तो नॉर्मल
dollar
पढ़ाई
versus INR, the exchange rates, will be seeing
हाँ
this
अगर लेट
particular
जाएगा
type
ना
of the
तो मिली
plots. And this sort of plots presents the uncertainty and variability within them. And it's very interesting to find out the forecasting for this particular dollar versus INR. And you can make money out of it, of course. That's why this forecasting area is so good. So, right now, let me tell you what is the formal definition of these particular topics that we are going to discuss today. So, we are going to discuss about time series, which is nothing but a set of observations, but they are recorded at specific times. Just like we have been using this Google, right? In Google, we write down what is going to be the temperature for tomorrow. And if you see for today, if you just click on the weather, it will be showing you temperature for next 10 days. Mostly the tomorrow's temperature and day after tomorrow's temperature would be very correct. But if you keep on scrolling, if you go to the temperature for the maybe next 7 days and you look at them now and you check it with the after 7 days temperature, it would be wrong. But what Google will do, they will keep on updating their model. They will be whenever today's temperature will be received, they will be putting that value and predicting again the rest of the values. So whenever, if you open your Google and look at the temperature for next 7 days today, if you look at the next 6 days temperature tomorrow, it will be changing. The values get changed because they keep on updating their model using the true values. So that's what time series is. If something is recorded at a specific time and we have a set of observations, it is known as time series. Time series could be of two types. Being a statistician or being a data science student, you must be having the knowledge that what is discrete data and what is continuous data. Based on having discrete points, we call the time series as discrete time series. Having the continuous time points, we call the time series to be continuous time series. There is very large scope of work to be done in continuous time series. Still, there are only few people in the world who works on continuous time series. Continuous time series applications are rarely looked after, just like ECG graph and all these things. But discrete time series are most of the time series that we'll be discussing today. So there is a large scope for you if you want to go get into the field of continuous time series. You might be getting a lot of recognition from there. What is meant by forecast? Forecast is an estimate of the probability distribution of a variable to be observed in the future. And forecasting is very difficult because we are talking about the future. And forecasting has fascinated people for thousands of years, something that is being considered either as a sign of divine inspiration or sometime it had been seen as a criminal activity. So that should be remembered before starting this particular job. So time series forecasting, we have daily collected data, maybe the temperature, maybe the COVID cases, taken for a regular interval of time. When we start working on the forecasting, I'm very sorry. I think I have a guest outside. I'll just be in a minute. Okay. Very sorry. Very sorry. Okay. So why we start working on any particular data, suppose we have the data of given maybe the power consumption for particular for several days, maybe electricity consumption for last 7 days. We want to forecast the electricity consumption maybe for the next day. So whenever we start working on this problem, it should be remembered that the following assumptions need to be satisfied before using any statistical forecasting techniques. One thing is historical information is available and past patterns will continue in the future. Unless like if just like here, suppose nobody could thought maybe if someone has to make a prediction in the year of 2000, they never predicted that in 2005 it will reach to 30. So nobody could predict that. So that's why we assume that the past patterns will continue in the future. What if the past pattern doesn't continue in the future? What will happen? So the forecasting things would be getting spoiled. That's why whenever people started predicting or forecasting the COVID-19 cases, they started working on the past data and some disease characteristics, but they forgot that in India, there was the celebration was going on, some particular voting system was going on, and many other things was going on. That particular thing they didn't incorporate in their model. That's why most of the models they predicted that the third wave in India will be coming in February or March, but it started coming back in December or early January. So that's where the forecasting fails, whenever this assumption doesn't hold. In a time series, we have several components, just like in this particular time series. There is a trend that like within some sort of time it got increased and then decreases like that. And then there is a seasonal pattern, maybe some of the particular things, just like if you observe the dengue patterns in India, you would be surprised to see that most of the time, whenever there is the rainy season, there are more dengue cases. That's why during the rainy season, because there will be water outside your home and that will make the mosquitoes to plan a dengue problem for all of us. So that's why during that particular rainy season, like government pushes people to use the like mosquito net and everything there to use for that. And that's what is called the seasonality of the data set. And then there is a cyclical component that some of the patterns got repeated over some time. And any particular time series can be decomposed into two segments. One is the particular thing is called signal, another thing is noise. Signal is received from the given data. Those signals are this trend, seasonality, cyclical component, all these things received from the data. And another thing is noise term, the component, the irregular component that is beyond our head. So based on that, we can, so that we can use the signal and combine it with the knowledge, because the signal won't be effort the 100% accurate. So we cannot always extract the 100% information from anything. So there will be a time series which will be recorded as a signal. We try to model time series in such a way that reduce and make it becomes acceptable. And in most of the stochastic time series or statistical time series problems, majority of the statistical models, they assume the stationarity of the data. That is nothing but, so stationary series means which is roughly horizontal, it has constant variance and no patterns predictable in the long term. So we can like, so there is the stationary series. If we have almost a constant mean and constant variance, so that the future can be very easily predicted from the time series. So overview of any particular statistical forecasting techniques in time series could be thought of. The time series is nothing but signal plus noise. What is signal? That is forecast extrapolate signals portion of the model and build a model on that. And noise is the confidence interval account for an uncertainty. And based on that, the area of statistical forecasting got enhanced, and thereafter we are going to look into those problems which this forecasting model can really solve. One of such problem could be like the weather forecasting, which has a lot of importance, and still in Google, in NASA, in everywhere in the world, they have their weather forecasting departments with attached with geography department, attached with some other departments, and they will be doing the weather forecast for several countries. If you are a good weather forecaster, maybe then you need to know time series forecasting, spatial data analysis, so that you can understand and make the forecast based on the given spatial values, just like the location values of the data, along with the time component, so that you can make right forecasting or more correct forecasting about the future weathers that you are going to forecast. So this is one of the areas in which many of the forecasters they work. Another very interesting area for all of you could be the stock price forecasting. So if you can be a good forecaster of the any stock, you are going to make a lot of money, and many companies they will be also hiring you for that. If you are going to be a good forecaster, so that is one of the area that is got a lot of hype, and there are a lot of money in this area. Another thing is sales of pharmaceutical products, or maybe sales of some drugs. So this is one of the areas, sales of number of calls. So like number of calls forecasting, solar energy forecasting, weather forecasting, then the like sales forecasting of any particular shoe sales in particular company like Khadim's or Bata. They will be started knowing that this particular product, what could be the forecasted value if you can give them, so they will make the stock in such a way that they can make the arrangement of those particular products which are going to be sold in much better quantity than others. So these are the sales forecasting area in which lot of pharmaceutical companies and other companies they also invest. Another very interesting area in which forecasting has its application and we can make forecast are the electricity consumption, or maybe solar energy consumption, or maybe some other thing which are related to energy consumption. So this is the something coming from the electricity consumption problem. What would be the electricity consumption for next 3 months? How can you make this forecast? So this particular area has already got a lot of bloom, and after 2000 people started working on area and lot of developments has happened in this area. Then there is another area in which people got interested from 2000, and I'm also someone who worked on that a little bit. Tried to give the predictions of what could be the future forecast of the COVID-19 cases. But yeah, statistical model they can make correct prediction maybe for next 7 days or 10 days or 15 days. We cannot make long-term forecast, because long-term forecast it cannot be happening, because you see, whenever you are going to talk about next 7, 10 or 15 or 30 data points, it's fine. But then suddenly maybe there will be a vote happening in West Bengal. So people will be jumping and they will be making all the all the presentations and all those like party politics, everything will be happening out there. And suddenly the COVID cases will increase. My data is not, my model is not going to incur that particular exogenous variable within that, right? So long-term forecasts are very difficult to make. Short-term forecasts are going to be reliable and are going to be more correct than the long-term forecasts. So that is one of the idea people started working. Now, the next question would be, what is easy and what is tough to forecast? I have ranked all these different forecasting problems in such a way that you can understand. If I ask you, time of sunshine this day, the next year, at what time there will be sunshine in your place? You may tell, like, if this is winter, it will be around 5 to 6. You are going to be correct anyway, right? If you are living in the Middle East, it would be around 6 to 7. If you are living in Europe, it would be around maybe 5, even 5, 4 to 5, or 4 to 6, something like that. And like that, we can really tell that because we are observing this thing over last 20, 30 years, whatever time we have spent in the earth. So this is very easy to forecast. Then maximum temperature tomorrow. So what could be the maximum temperature tomorrow? Suppose, like, if you are staying back in Kolkata, it's kind of winter there. So you may tell that like tomorrow's the highest temperature could be approximately 30. It may not be over 30. It's very easy to tell. You don't need any model for that to do that. But if someone asks you daily electricity demand in 3 days time or Google stock price tomorrow, you need to build some models and based on that make the forecast. Those forecastings are going to be little challenging, and maybe the Google stock price in next 6 months time would be the toughest thing to forecast. So because you do not know what is going to happen in next 6 months. Maybe there will be no COVID, or there will be COVID once again. There will be some other things, we don't know that, right? So those uncertainties, we can model uncertainty, but for short-term arrival, just like for the nowcasting, just like for the next 7 points, 10 points, 30 points. More than that, whenever we will be trying to forecast, it's mostly gonna fail. So what are the factors? What make the forecasting problem easy? If we have a data set for which we have good understanding of the factor that contribute to it. Just like for the dengue cases, what are the factors that contribute to dengue cases? Maybe the temperature, maybe the waterfall, maybe the wind speed. If we have all these data sets with us, which contribute as an exogenous variable on the number of cases of dengue, then if we want to forecast dengue cases with this sort of information, then we can measure them correctly. And we need a lot of data to be available. We cannot forecast if we have only 100 or 10, 20 data points. It's very difficult to forecast if we have very small number of samples. The future is somewhat similar to the past, unless suppose in the data, the dengue cases was around maybe at most 5,000 for India. Suppose in the next year, suddenly it reaches 100,000. Can you predict that? Because within your training data, there was no such point more than 5,000. So you cannot go up to 100,000 from there, right? So it's very difficult unless we have the future is behaving very similar to the past. Because just like in COVID cases, people didn't know, because people didn't know that in between election and everything will happen and we'll have the third wave very fast. So that's the thing. The sum of the like uncontrollable variables can come and they can waste your all the forecasting things. And the forecast cannot affect the thing we are trying to forecast. So that should be another thing. It should be taken into care. So whatever will be forecasting, just like if Jeff Bezos or maybe the founder of Tesla, so they tell something about some stock price, they said you to buy this particular cryptocurrency. It's nothing but people will jump for that from the next week, from the very next day, I say. And their forecasts are going to be affecting the actual values. And that's what happens in stock market. If like Junjun Mala, he said something about some of the top stocks, people start buying or people don't buy if he says this stock won't be something worthy to buy. So that's what happens whenever a big bull or something who controls the market. That time your forecasting may fail because you didn't consider that he will be telling that don't buy this particular stock. Okay. So right now, people may ask you that, so okay, enough of the understanding of how forecasting got up to here and where we can apply, when we can apply, all these things got cleared. So how do we make the forecasting? That's the area in which you, if you are very interested to study, I'll give you a lot of reference and I'll discuss what are the different type of model that exist in the forecasting literature. So let's start with the 1950s model, naive-based method. What is naive-based method? Suppose someone asks you, what would be the temperature for tomorrow? You said, what is the temperature for today? They will tell maybe 20 degrees Celsius. You will tell 20 degrees Celsius. The answer is for tomorrow is going to be 20 degrees. Then you are following some method which is called naive method. That is also a method. You are just telling what is happening on the last day, that is going to happen for next days. That is very easy to understand, but very unuseful, right? Then there is another sort of method that came back in 1960s, named as simple exponential smoothing method. And the modern version of simple exponential smoothing is popularly known as ETS method, which is very famously used in time series forecasting. Then there is, back in 1970s, another literature started growing, is called autoregressive moving average methods, which statisticians, they love a lot. They mostly love simple exponential smoothing, halt to winter, ETS method, and these autoregressive methods. They are in love with these methods because autoregressive methods uses the past observations along with the random errors to model, to make a forecasting model based on which you may get some good amount of forecasts. It was created by someone whom you must be knowing, is called George Box, who told that particular line, all models are wrong, but some are useful. He was the creator of this ARIMA model with Jenkins. Then back in 1980s, there was a model called fractional autoregressive integrated moving average model. It was introduced by Granger. Granger is the person who introduced something called causality test, and he got Nobel Prize in economics for his contribution in statistics and econometrics. He invented this particular model, fractional autoregressive integrated moving average model, that is used for when we have a time series with long-term memory. Arfima model is the most useful one. Then there people started working on Tong, Tejasvita, they started working on threshold autoregressive model on nonlinear time series models. So threshold autoregressive model, self-excited threshold autoregressive model are some of the nonlinear version of autoregressive models, because autoregressive models are linear models. These models are nonlinear models. Then back in 2000, there is a very famous competition in forecasting which happens almost every 5 years these days, almost every 3 years right now it's happening. So that particular competition, actually, if you are a forecaster, you can participate to that competition. There is a huge prize you can earn, and you will be learning many things. So in that particular competition back in 2000, that is known as M3 competition, the winner was Theta Method. Some people from Greece, they introduced this Theta Method for forecasting, which is nothing but later on found out a shifted, or not shifted, drifted ARIMA model. So later on, Rolf Hinman established that theta is nothing but a drifted ARIMA model. And there is a lot of literature out there. If you look for theta method for forecasting, there is like this method started growing from 2000 to 2022. Then there is another method got introduced back in 2006 to 7, is known as wavelet autoregressive integrated moving average model. Wavelet transformation, or like Fourier transformation, have been introduced with the time series data to convert the data into time and frequency domain, and then one fits the ARIMA model. So this is one of the area in which people started working from 2006 to 7, and also still now in COVID prediction, this ARIMA model incorporated with ARIMA was really working better, and we have written a paper on proposing an ensemble of ARIMA and WARIMA method which gives more robust forecasts than the usual methods that is out there. And then there is another model called TBATS model. So it is nothing but a model with ARIMA which incorporates the trigonometric coefficient, the trend, seasonality, and individually model them together. It was introduced back in 2010 to 12 by Rob Hinman, International Journal of Forecasting, and some other journals. So that got a lot of emphasis during the past. But I think this among all these models, based on my personal experience, I still find for most of the data sets, it's hard to beat ARIMA model. So whenever you are going to learn it very carefully. It has lot of application even after 50 years of its proposal. Then there is another area of forecasting which talks about the machine learning based forecasting. In this area, there are a lot of models from artificial neural network to recurrent neural network to autoregressive neural network to reservoir computing to support vector regression, random forest, XGBoost, the very new in 2018 Facebook proposed Prophet model, that is the deep learning model they proposed, and DPR model that was proposed in 2020. All these are different machine learning model have been introduced so far. There are some other models which I haven't categorized out here, but these are short of some of the models which are very interesting to learn. Then, if you are someone who doesn't like frequentist thing, who is I'm Bayesian, I don't get any particular estimated value of any parameter. I try to get the prior distribution of that. Based on that, I want to understand the future. If you are someone who loves the Bayesian approaches, if you are taught about with that, then you would be falling in love with Bayesian ARIMA model, Bayesian neural network model, Bayesian structural time series model, and Bayesian maths model. Then, after all these things was going, there was a significant contribution from the people who have been trying to work on combining these things. Just like people started working on ensemble model. So the very first ensemble model, if I have to tell, was proposed back in 1970s, known as combination of forecast. How can you combine the forecast? Let me tell you a very easy example. You take ARIMA model, neural network model, and BSTS model. You take 1 by 3 of ARIMA model plus 1 by 3 value of the machine learning model plus 1 by 3 of the forecasted value of the BSTS model. You combine them and make a forecast on your own. That was the very first idea of making an ensemble or making an arithmetic mean of the different forecasters, proposed back in 1970s by Gates and Granger. Again, Granger will come in the picture. So that model got a lot of emphasis. Even still now, we could find out a better strategy to find out these weights. Alpha 1 into ARIMA forecast plus beta 1 into ARNN forecast plus gamma into BSTS forecast. How do we estimate alpha beta gamma? We proposed a new method called optimized deep learning model, which gives an idea how to combine 3 different forecasts to generate better forecasts. There is another method called XGBoost method. There is another method proposed by Monash University people that got the runners-up in M4 competition is called F-forma method. So all these are different ensemble methods have been proposed, and there are few hybrid methods that got a lot of attention these days. It starts with the very first work of Zhang back in 2002. After that, very recently in 2019, we wrote a paper on ARIMA ERNN, hybridization of ARIMA model with ERNN, that paper got a lot of attention, and people are using that particular model in some of their applications. There is another method called exponential smoothing incorporated with recurrent neural network model that won the M4 competition that happened in 2019. And then very recently, we worked on some hybrid model with wavelet autoregressive neural networks. So these are the few things which we have been doing, and many other people have contributed. My contributions are, of course, the least I believe, but I also tried to, with my team, I tried to work on this particular area. And this area is blooming because Statistical model, they have their own advantages. Machine learning model, they have their own advantages. If you combine them together, the advantages, you can restore their advantages and ignores their disadvantages and create something which are beautiful and as well as which are going to make better forecast than the usual ones. Then there is another area which got a lot of attention these days, is known as multivariate forecasting. Multivariate forecasting shouldn't be confused with multiple linear regression. Multiple linear regression is something when we have one y, we have several feature variable or causal variables. So we have one explanatory variable, several causal variable is known as multiple linear regression. Multivariate means we have several different particular y1, y2, y3, like that. We have several different features which we are going to forecast. So we have the several output variables. We want to forecast all the output variables together. That is known as multivariate forecasting. Suppose we want to understand what is going to be the GDP for next year together with maybe the exchange rate, maybe the other macroeconomic factors. If you want to forecast them together, it's a multivariate forecasting problem. And vector autoregressive moving average model, which is nothing but an modified version of ARIMA model, is going to help you for that. There are state space based model for multivariate forecasting. LSTM model, long short-term memory network, is very useful for multivariate forecasting. And in modern days, in last 3 years, people are using transformer-based deep learning model for multivariate forecasting. So this particular slide gives you a wholesome idea about what are the forecasting methods are there, which you need to learn if you are really interested to work on this particular field. Now I'll come later on how do we learn these methods, from where to learn. So what are the advantages of stochastic models or statistical models? They are based on the empirical data. They observe with the objective to measure the uncertainty. They are computable, they are replicable, they are testable, and we can get the prediction intervals from there. So suppose statisticians, they were always bothered about the interval estimation rather than the point estimation. Point estimation is something we'll be taking the mean of that, we'll be getting some point estimate. But what is the interval? What is the interval value in which the temperature of tomorrow is going to learn? So that's what we are more interested about. So from the statistical perspective, these are the advantages of the stochastic models. Whereas the particular ML models, they are very smart algorithms. They have very few assumptions. They can be applied to big data problem. They solve the problems which traditional methods couldn't handle, just like very large sample size data. They have very strong emphasis on out of sample predictive performance, and they have recognition that many problems are prediction problem, not p-value. So statisticians are currently still with the thing that if p-value is not this, we are not going to work. Prediction is the thing that mostly matters than the p-values. So there is a very strong write-up against p-value in American statistician back in 2010, and they started telling that p-value is not only the thing you should be looking for. So you need to move beyond p-value. You may write an article like in forecasting, how did we make the progress to go beyond p-value. Not understanding the p-value, we started understanding what is the forecasting accuracy, and we wanted to make a forecasting model which will give better forecasting accuracy for the future. So there are various areas in which you can look for. Maybe if we have annual data sets, some of the models are more useful. If you have monthly data sets, some of the models are useful. If you have weekly data set, the other set of models are useful. So there is a very interesting survey paper that we have written very recently, which has application with COVID-19 cases, but we have given all the codes of running most of the models that are discussed above. So how do we implement all these modes, all these models, and their codes have been given to our GitHub page. This particular paper would be a must read for you if you want to know the wholesome idea, whatever I am discussing today, what are these models, how these models are grown, and what are the references you need to go for to learn these models in more depth. And then finally, so we talked about what was the past, the Babylon time and everything. crystal ball and everything, all those things. Then we came with what are the problems in reality in present we are trying to solve with this statistical and machine learning model. Right now, I'll be just taking another 5 minutes on what is the future of this forecasting. Right now, people are more interested about interpretable neural networks and interpretable deep learning model. Very recently, we have submitted a paper on creating a probabilistic interpretable neural network model for making the forecasting for economics, epidemiological, and various other data sets. This is one of the area people want to get some forecasting model which is interpretable but more accurate than the standard models. So that's one of the area in which we can work. Then, if you haven't read a book called Black Swans by Taleb, so you may need to go for that book. That book talks about what are the randomness present in the real life, how do you misunderstand the randomness. So that black swan methodologies, will we be ever able to forecast black swans? That's a very interesting future problem. Maybe if you can solve, it's gonna be a millennial problem to solve this problem. Prize for this thing. And does we need more data for making better forecast? Can we really create a model which can make the forecast using a very small sample data sets? If you can make some model, it's going to be very useful. Will AI take over forecasting? That's another question many people tell. What AI can do in AI, you can build all those algorithms, you can give those algorithms, it will make the forecast. But finally, when and how it fails, that is the person you is going to design. And the standard algorithm, if one algorithm is working for one problem, it is not certainly granted that is going to be working for another set of problems. So human interface with AI would be always recurrent. So you need to work on something which, even if you try to make an AI system for making the forecasting, but you would be the creator of that. Once one has to like be at the front to make some more robust model, because the predictive models, they work for some set of problems, they do not work for all set of problems. There is no universality, and that is what known as no freelance theorem in machine learning or optimization. So you are not going to get any freelance even after this talk, as well as in real life when applying a particular model, you are not going to get the best sort of accuracy, interpretability, and understanding of the model with the best accuracy with a particular model. So it's always you will be having to trade off between the bias variance and everything to design the model. Are there many jobs for forecasters? Of course. So in most of the finance companies, in most of the pharmaceutical companies, in most of the big companies, they hire forecasters. The person who is working on forecasting, he will be knowing not only statistics but machine learning, economics, and many other things. So it's a win-win situation for everyone if you are from forecasting. Just like you saw, many of the models are very strong statistical model which will be requiring your background in linear regression analysis, multiple linear regression, ridge regression, and all these things. And then machine learning background will be required to work on that. You'll be requiring Bayesian background if you want to work on Bayesian machine learning, and the combination will be requiring all of them together. So anyway, you will be an expert who can serve the purpose of the company. That's why someone, if the person is a forecaster, they are going to have a chance to hire more than a person who is only working on machine learning, working on maybe regression. You are working on both then. So what are some thoughts on forecasting? Most statistical problems are better expressed as prediction problems. Machine learning and statistics, they are converging together. And if you are someone, I'm a statistician, I'm not going to learn it. So after next 10 years, my forecast will be the existence will be a difficult, because the machine learning community, they capture most of the things from statistics. From categorical data analysis, they have named this as classification or supervised learning. Regression, they have named this as supervised learning. Whatever we did in class studying and everything, they have named it as, or multivariate data analysis, they have named it as unsupervised learning. And still, like, both the things are converging very fast. And it will become very common to compute prediction intervals for machine learning methods in which statisticians can contribute a lot. Because whatever models are developed in machine learning, they only talked about point estimates. They don't know how to compute the prediction intervals. So you are going to be someone who can help them out. Together, you can work with them and create something very new. So it's very important to understand that the most significant research that is happening these days are from the joint areas, just like interdisciplinary research. Being a statistician, sitting in a room, not discussing with anyone was fine before 2000. You could have solved some theoretical problems. This particular estimator is a sufficiently complete. It was fine. These days, you need to work on the data because mathematical discipline thought process of statistics was early 2000. Right now, if you want to be a mathematician, be a mathematician. If you want to be a statistician, be a data scientist. So that's one of the things that is happening out there. And if we follow that trend, we should be more interested about emphasizing more about the ability of the model to make the prediction, the ability of the model to make the forecast, rather than just sticking with the p values and many other things. Whether the estimator is sufficient or efficient, that won't be a problem for us because getting a sufficient estimator, getting a complete estimator is like not is a joke, of course, because we cannot get that in real life problems. And statisticians need to learn the ML based forecasts because otherwise you will be lagged behind. In some cases, some of the problems, if you have big volume, velocity of data, and if it is a big data problem, your statistical model will fail. You need to know the ML based method, which will be helping for that. We need to teach ML methods alongside statistical methods in university. So currently I'm teaching here in BSc Mathematics course. The courses I'm taking is multivariate data analysis, in which I'm teaching for bachelor students. I'm teaching the whole regression analysis and multivariate data analysis tools, just like PCA, FA, clustering and everything. And I'll be also taking there one course on machine learning. So BSc Maths program these days, MSc they definitely has. BSc Math program, they also have these courses. So we need to teach our students in India as well some of the machine learning things. At least some of the books should be taught within the scope of the course in forecasting as well as in general statistics. So one of the final comments that I can tell you. So if you become a forecaster, you are not going to be called the smartest than everyone else, but maybe you will maybe having the your merely has its ignorance better organized. So you are not going to be the topmost person in the world, but if you learn it properly, so you would be understanding the uncertainty of the like about the future and uncertainty of some of the phenomena in a better way than others. That's what the beauty of learning this subject. The very next question will arise, sir, how from, where from should we start? Which book should I follow? This is the most practical book, and this is written by one of the most popular forecasters in the world by Rob Hinman and George. So they wrote a book, Forecasting Principles and Practice, which is freely available with all the R codes data sets within that. So you can read this book from practical perspective. If you want to, if you are someone who likes the theory, of course, everyone likes the theory as well as practice. Maybe for the theory, you may follow the book by Time Series Forecasting book by Box itself. So George Box wrote a book on that, which has its ninth edition or 8th edition released in 2015 or 14 like that. You may look into that book. And whatever models I talked about here, a list of models I presented here, most of the models details, a little bit of details of these models are presented in this particular survey paper, which published very recently in 2022. And as well as we have our own in 2021, and we have our paper, this paper on forecasting, which gives you a very tutorial based paper, which gives you very easy understanding of different forecasting models for forecasting the COVID-19 pandemics. So that could be another duty for you to start with. Maybe in case you start with, you go a little beyond, then if you have any doubts, if you have any question, or if you want to read some more books on any particular topic, definitely you can find me on Google and other places. In LinkedIn, you can send me a message. I'll be happy to help you out with other resources. So that's it from my side. I think I have already covered more than an hour. So what are the questions you have? Please feel free to raise. I'll be happy to answer.
I request the audience to drop their queries in the chat box or unmute themselves.
So I can see Anshuman asks that he is looking for a project in time series forecasting, something like that. Please give me some suggestions. So the first suggestion is read the book, then do any project. Without reading the book, the project won't be possible. So that book is very much required. Then pick up a problem. Maybe the COVID forecasting problem, epidemic forecasting, maybe the exchange forecasting problem, any problem you take and try to handle with the given knowledge that you have studied so far. Yeah. Then Parvati wrote, said this one. I don't have any recording, but if you want me, I can definitely upload this particular slide. Please send me a message over LinkedIn or send me a mail so that I can send you the PPT, this particular slide that I have sharing during the class. And thank you, Ayushi, then Abhishek, Pranjali. Could we have the link to access the particular time series techniques I told? Like that particular slide have been created by us, so it's like I'll be definitely what I can do. I'll be sending you the slide. In the slide, there is the link of this particular journal and papers that I have mentioned. So please send me a message or mail so that I can share it with you. Even otherwise, I'll upload it in my web page. So in case you have no idea about my web page, so this is my web page in which I'll be uploading the particular slide. And thank you, Tanisha, Vidhima, Sunkara, and Nitika, Adityo. Yeah, thank you everyone. If you have any sort of idea or queries, please feel free to send me message, send me mails. I'd be happy to reply. I'd be happy to share the PPTs and whatever link I have, whatever information I have. Okay. Thanks, Adityo, Madhurima. Give some suggestions to get place in IT software set. I don't have any idea about IT software. Um, I have very less idea about. So Jasprit asked a very interesting question. What is Arima X? Sarima X. So Sarima X is like whenever we have a seasonal time series, we use instead of using the Arima model, we use Sarima model. Seasonal autoregressive moving average model, integrated moving average model. Sarima X is nothing but whenever we have a time series and we have some other exogenous variable information. We have some other regressor variable which have an impact on that. Just like consider the dengue cases. So for dengue cases, we have the dengue cases along with that, we have the data of temperature, rainfall, and some others. So for those particular problems, Sarima X will be useful. So it's like Sarima model in the presence of exogenous variable. Digvijay asked for books for stats and machine learning for starting from the scratch. Maybe if I have to look from the scratch, okay, from the scratch means if you have to look for ISLR book, ESLR, and this particular uh, FPT3, the book I mentioned, Forecasting Principles and Practice. These three books should be the thing that you should be looking for. You just Google ISLR book, SLR book, FPT3 book, you will be getting it in Google. Okay. So are you requested to fill the feedback form? I think that is for the students. Thank you, Manisha. Anyone else have any questions? Thank you, Shaloni. Thank you, Jasprit. For those who would be looking for this particular slide, so let me just tell you where you will be finding this. So if you can see, this is my web page. Under the web page, I think I'll be uploading it. Where is it? Under teaching under my talks, I'll be uploading this particular slide by today. Okay. I'll definitely upload this slide out here under my talks in my web page. So you just Google my name, you'll be finding this web page. And under this teaching, under my talks, I'll be uploading this particular slides for those who will be looking for this slide. Okay. So just look into in this particular link, maybe by tonight to see the slide. Okay, and get the slide.
So I think that we have no more other queries.
Yeah.
So I thank you, sir, for such an insightful and deeply explained and committed session. And I'm also sure that the participants gained something from this webinar. And I also thank them for being such
I
a
hope because in India we don't have too many forecasters. In India, if I have to tell how many professors who work in forecasting, because I was someone during my masters, I was thinking to do PhD in forecasting, and then I was looking for who are the people who works in forecasting. I found in at ISI there are only 3 people who works in forecasting, and there are few economists who work in forecasting. One is in there in IGIDR Mumbai, another person is in Delhi School of Economics, and there are a very few people from Calcutta University, Pune University who work on forecasting. Maybe not even one in statistics and economics department. So we lack forecasters. Well, we love astrology. We love astrologers in India. We hate forecasters. That shouldn't be the case. We need more forecasters than astrologers. Yeah. Okay.
thanks a lot, sir.
Yeah.
And
Thank you so much.
I thank the participants also for being absorbing the content and maintaining the decorum. And sir, we look forward from you again hosting you, sir.
Yeah. Sure.
So it was
Sure.
a really good session, sir. Thank you.
Yeah, thanks a lot. Thanks a lot. See you all. If you have any doubts, please feel free to contact me. Okay. See you. Have a nice day. Okay. Bye.